This is the set number 6 and it is the last set of the chapter Haloalkane and Haloarene, and today the precise topic is CH3, CHCl3, chloroform, iodoform and DDT. Lots of question on this of entrance exam has been solved and minutely follow this. First question is very important. This is chloroform CHCl3 plus O2X. What is that X? To give you COCl3 plus HCl. Answer: sunlight and air. The X is sunlight and air. And the specialty of this reaction is that the COCl2 is a gas and COCl2 is called phosgene and it is very poisonous gas. So phosgene is prepared. So you should be familiar with the gas phosgene. Very often this question is asked in different form. Number 2, you go to phosgene, you have come across with this one, is commonly known as, a lot of exam, in lot of various exam it has been asked. So phosgene is commonly known as, so the structure of phosgene is molecular formula is COCl2, it is carbonyl. So this is called carbonyl chloride. So question number 2, phosgene is commonly known as carbonyl chloride. Am I right? Number 3, salicylic acid can be prepared for Riemann-Thielemann equation. Actually, Riemann-Thielemann equation is with phenol. What is Riemann-Thielemann? Question number 3. I am talking about question number 3, salicylic acid. So let me give a little idea on salicylic and salicylic acid. Very often you know, most of you know, this is salicylic and this is salicylic acid. Am I right? And these two can be prepared from Riemann-Thielemann, a very famous reaction. You have got it earlier. Salicylic or salicylic acid can be prepared from Riemann-Thielemann reaction, and the main component of this Riemann-Thielemann reaction is, first it should be phenol, and here it may be chloroform or it may be carbon tetrachloride and an alkali. These are the things you should know to get salicylic acid. Salicylic acid can be prepared or salicylic. So the fact is that you are asked salicylic acid, means you need to prepare this salicylic acid. Salicylic acid can be prepared when it is treated with phenol, is treated with carbon tetrachloride and sodium hydroxide, you will get salicylic acid. And at this point I want to mention, if you don't apply CCl4, if you apply chloroform, then this will give you salicylic. If it is chloroform, salicylic. If it is carbon tetrachloride, salicylic acid. Am I right? So very simple. Since we are dealing with chloroform, so we have taken out this phenol. In second chapter I will again get this question, alcohol, phenol. So question number 4, war gas is formed from PHC, CCH, C2H2, zinc sulfate, CH3. It is also asked. War gas. What is war gas? Let me first explain. War gas is formed from chloroform, because we are concerned with the chapter haloalkane, haloarene, and here the point is chloroform and iodoform and DDT. So war gas is prepared from chloroform. So how it is formed? Say, what is chloroform? If you write the technique of writing chloroform is, you can write in splitting form, CCl4 skeletal form, and if you make to react with nitric acid, so you write nitric acid in this way. The main component in the reactions are chloroform and nitric acid. So when chloroform and nitric acid reacts, water evolves out, comes out, so you get CCl3NO2, and this is a very poisonous gas, and it is always termed as war gas, and its another name is chloropicrine. Its another name is chloropicrine. CHLORO, CHLORO, chloropicrine. Nitrochloromethane. So chloropicrine, it is a war gas, and one of the important thing here I want to mention is that this gas is utilized in the First World War, where Russia used this gas in against Ukraine. Am I right? So the main impact of this gas is that it acts on, when it is applied, so it causes skin irritation, heart, mostly it causes skin irritation, heart and lung diseases and problems, and it is carcinogenic in nature, means it causes cancer. Hence this war gas is very dangerous. Next, question number 4. CCl4 treated with AgNO3. A lot of exam the question is asked, and it is a question to make you fool. A lot of options are given. The product will be this and that. Answer: there will no reaction at all. And question number 5, no reaction at all, because carbon tetrachloride is covalent and it doesn't furnish Cl ion. Hence there is no reaction with AgNO3. Answer: no product will be formed. No reaction option is correct. So question number 6, if we use pyrene in place of chloroform. So I have written here CCl4, but in exam it is not written CCl4. The commercial name of CCl4 carbon tetrachloride is pyrene, and it is sometimes when it is used in extinguishing of gas fire. So when pyrene is used, again it gives some poisonous gas. So that pyrene is nothing but carbon tetrachloride. In place of chloroform, if you use, a bit earlier I have told, when it is chloroform, it is salicylic acid, and when it is chloroform, it is salicylaldehyde, and when it is CCl4, it is salicylic acid. So in place of CCl4, it is written pyrene. So instantly you should keep it in your mind that pyrene is nothing but CCl4. So next is a bad smelling substance formed by the reactions of alcohol, caustic potash on chloroform and aniline. It is a very famous reaction. Again you will get this reaction in amine chapter, and here a bad smelling reactions of alcohol, caustic potash with chloroform and aniline. You are given this is aniline. This is aniline, and you are asked to make it to react with what? Chloroform and caustic potash, means potassium hydroxide. Then it is a very famous reaction. Isocyanide. Isocyanide, NC means benzene isocyanide, and it is very bad smelling, foul smelling compound. It is used in carbaleman test. So due to this fact, it is very often asked in the exam, and it is given or grouped in this chapter because here chloroform is used. Again in amine also this may be a question, because here amine is there, aromatic amine. And at this point, one important point is that very often in entrance exam it is asked when carbaleman test, when NC isocyanide is prepared. So it may give 1 degree aliphatic amine, 1 degree aliphatic amine, or 1 degree aromatic amine. Both can show iodoform reaction and carbaleman test. Next, on heating chloroform with aqueous sodium hydroxide. What is chloroform? This is chloroform and sodium hydroxide. what's happened? Will replace this. So what we get, and this is a very unstable one, instantly one water molecule lost, so you will get HCCOOH. So if you don't apply the trick, you can't find the answer. So when chloroform react with sodium hydroxide, it gives this, and all Cl is replaced by OH, and unstable compound is formed. On losing water molecule, it gives this, and when there is sodium, also in place of sodium, sometimes it is Na. When there is sodium, in place of H, there you give it here plus and minus. So sodium formate is formed. Next point is iodoform reacts with silver powder. It is very important. You can't imagine the answer. Iodoform reacts with, what is iodoform? CHI3, and silver, it is in powder. Silver powder gives you give two iodoform in this way arrange, and you apply the technique. So what you get here, CH means CH triple bond CH means acetylene. You never imagine the answer C2H2 or C2H2. When iodoform made to react with silver, you can't imagine you will get acetylene. So CHI3, and here also you in reverse order you write I3CH, and 6 molecule give you this 6HI AgI, means you are getting acetylene. So it is very important reaction which you may not answer the question. So this is over. On heating chloroform, ethylamine reacts with chloroform in caustic potash. Again we have already told what is ethylamine, CH3 CH2 NH2 on reacting with chloroform and potassium hydroxide. So already I have mentioned it is a carbon-11 reaction. Chloroform, since we are dealing with chloroform and potassium hydroxide, it gives you ethyl isocyanide. It is again foul smelling compound, very bad smell. So it is aliphatic amine. Earlier case we assumed it aromatic amine. So 1 degree aromatic or aliphatic amine will show you the carbalaman test. If you give it 2 degree or 3 degree, it will not show. This is 1 degree amine. So next one, phenol with chloroform and potassium hydroxide. I will not explain this once again, because earlier I have told that when it is phenol and here carbon tetrachloride, it is salicylic acid. When it is phenol and here chloroform and sodium hydroxide, it will give salicyldehyde. Your answer will be salicyldehyde. So you have already mentioned this one. So 11 is over. So this is again very important reaction. Also you have done it at the very beginning. It is in another way question was asked. So here you are given CaCl3 plus half of oxygen sunlight. What is the answer? You see, and in lot of exam this question is asked. Answer phosgene and HCl. So when chloroform reacts with air in presence of oxygen, we get phosgene COCl3 plus HCl, and this is another name is carbonyl chloride. Am I right? And it is a very poisonous gas. It is very important. Very often question is asked. Next one, a compound A has a molecular formula C2Cl3OH. The compound A, you see, this is a type of question very often asked. A compound A molecular formula is CCl3OH. Am I right? Minutely follow the question. It reduces failing solution. Means when it is react with failing solution, in aldehyde chapter we will come across this one, failing solution, it gives red PPT. This is red PPT, means it gives response. So failing solution when reduced, it indicates there is CHO group. That confirms that A should have CHO group. A should have CHO group. So if there is no CHO group in A, failing solution will not be reduced. So it will be oxidized to other one. Anyway, so now the question, whether there is CHO group, there is two CHO group or many CHO group or one single CHO group, that should be verified from question. See, it reduces failing solution and on oxidation gives monocarboxylic acid. So if you oxidize it, it gives you carboxylic acid. Means see, you can write it C here, carbon 2, one carbon here, and CCl3, and another carbon you arrange in this way. So very famous compound. I don't know whether recall it or not. In earlier sets I have already mentioned, it is chloral. In DDT you have got it is chloral, and I have told you write CH3CHO, in place of H3 you place Cl3, that you will get chloral. It is chloral. So when chloral is made to react, means when the compound A, that compound A may be written in this way, is oxidized, the second point, it gives CCl3, and that COHO becomes COOH. They have told you it become carboxylic acid, and it is monocarboxylic acid. Means one COOH is formed, is there only in this compound. No question of more CHO. So on confirming that it has CHO group, when failing reaction is reduced, we confirm there is a CHO group. And second point is how many CHO group is there. By the second point, that on oxidation gives monocarboxylic acid, one COOH group, means one CHO transformed into one COOH, means there is only one CHO. There is one CHO, not more. So now the question is, next part, A is obtained by action of chlorine on ethyl alcohol. Third part, A is obtained, that A is obtained by action of ethyl alcohol with chlorine. So it is oxidizing agent. In my different classes I told you that oxidation means CHO become CH2OH become CH. You just apply the trick, or you remove hydrogen. There are lots of ways are there. In my earlier classes I have mentioned, I don't want to repeat these things. So one reacting with chlorine, it gives this one, and again this one, on further reaction with chlorine will give you this hydrogen will be replaced by Cl3CHO. So is not it A? That A is Cl3CHO. So your question is, what is A and B? So A is already given. What is B? Monocarboxylic. The answer B is this, and A is written in this way, but in the option you write A in this way. I have written already. not C2Cl3CH. You write CCl3CHO. So your A is, because there is a question of number of CHO, so your A will be, through different point we have come to conclusion A is CCl3, and this C should go in this way, and B is CCl3 COOH. So A and B are given. This question is again asked in different exam. Yes. Now question number 14. Iodoform is formed with iodoform. A lot of question I have already explained in set 2 or set 3 I have. So till I am going to this one because this question asked in JEE. Iodoform is formed with ethylamine, acetophenone. A lots of other options are there. I have chosen these two only because this will give you some trouble in you. Ethylamine. Answer, ethylamine will not do. And with other options I have chosen acetophenone. What is acetophenone? You see the acetophenone structure is, this is acetophenone. You should have knowledge on structure. This is acetophenone, and I told that this compound where CH3O group is side by side will very often generally show iodoform reaction, and hence this will show iodoform reactions with alkali, and we will get CHI3 very easily because OCH3 is there. So answer is acetophenone will show iodoform reaction because CH3O is side by side. Next question number 15. Again, iodoform is formed with ethanol, methanol, formic acid, and lots of in various entrance exam it is asked. So let us take first one, ethanol, CH3CH2OH. And here iodoform, in my first or second class I told a lot of things regarding iodoform. I told you alcohol, only alcohol, 1 degree alcohol is ethanol. It is 1 degree alcohol will show iodoform reaction because alcohol which on oxidation, again the trick, on oxidation this gives you CH3CO. Alcohol which on oxidation will give you, primary alcohol on oxidation will give you CH3CHO, means aldehyde. Means you are getting CH3CO go side by side, CH3C double bond O. So you are getting this side by side. So hence ethanol will show you iodoform reaction. The question number 2 is over. Now, sorry, 15 is over. A sample of chloroform being used as anesthetic is tested. When chloroform is used as anesthetic purpose, as anesthesia, before that a test is made. So you are asked with what the test is done. Failing ammonical CO2, Cl2, AgNO3 and others. Question is asked in entrance exam. Answer, when chloroform is pure, nothing impurity is in there. When it is made to react with silver nitrate solution, no reaction occur, no color change, nothing will happen. Chloroform with AgNO3, when chloroform, yes, chloroform when it is in pure form, is made to react with silver nitrate. If there is no reaction, means it is pure. So chloroform before testing as anesthetic purpose is tested with silver nitrate. So answer is silver nitrate. So this is the reaction asked in joint entrance exam. So it is very simple. See, this is toluene, and you are asked to make to react with Cl2 with H nu. When it is H nu, side reaction will occur. Already I have mentioned these things. Side reaction will occur. So you will get CH2, one substitution reaction will occur. So this will give you this. Am I right? So this is free radical mechanism, substitution free radical mechanism. On further reactions with this, we will get all hydrogen will be replaced. So one chlorine is already there, other chlorine is there, and other chlorine is there. So one chlorine is there and two hydrogen will be replaced by two other chlorine. So you will get this one. So a bit earlier I have told you in chloroform CaCl3 there is 3 Cl group when it is made to react with sodium hydroxide. So 3 sodium hydroxide, 3 OH group replaces chlorine. The same reaction when it is made to react with sodium hydroxide. So here OH, OH, OH will be replaced. Again it is very unstable. Automatically it will give you a stable compound with releasing water. Am I right? With releasing water molecule. So you are getting carboxylic acid. Am I right? So in the last part you are asked when carboxylic acid means D is made to react with sodium hydroxide. So what will happen? Simple, this will be replaced. Answer COO-Na. Am I right? So your answer E is this. This is to prevent formation of phosgene. So some compounds are generally added with chloroform in order to avoid the accidental addition of oxygen, which makes oxidize to prevent or to prepare phosgene gas. Am I right? To prevent formation of phosgene gas, if there is accidentally oxygen already in their bottle where chloroform is kept, so some compound is used, and in the optional lots of compounds are there. So there the answer will be ethanol. Ethanol is mixed with chloroform to prevent formation of phosgene gas, because ethanol is lighter than chloroform, so it remains on the surface of chloroform in floating way. So it reduces the chances of oxygen if present in the bottle to react with chloroform to produce phosgene. So in floating condition, C2H5, ethanol remains in the upper surface of the chloroform to cut the possibility of what oxygen to come in contact with chloroform to make phosgene gas. Answer, ethanol is added. Structure of dichloro diphenyl trichloroethane. Though it is not a correct name, till it is asked in the exam. Dichloro diphenyl trichloroacid. Is it dichloro diphenyl trichloroethane? Means DDT. And structure is, I have already given it. So for your understanding, once again I am showing you the structure. I need not to explain, I think. So this is the structure of dichloro diphenyl trichloroethane. Ethane. So next one, CCl4 when react with steam. I have again written pyrene in exam. It is asked pyrene. When pyrene is made to react with pyrene steam. Steam means there is water at 500 degrees centigrade. What's happened? Pyrene is nothing but carbon tetrachloride. When it is used in extinguishing fire, again peculiar thing will happen. If you give steam and 500 degrees, phosgene gas and HCl will produce. You are asked what gas is produced. Answer, phosgene gas is produced when pyrene is used at high temperature 500 degrees. Acetone with chloroform. This is a bit peculiar reaction. What is acetone? CH3 CH. Unless you apply the technique, you can't answer it or can't write the answer. You are asked what of the following compound is formed. It is acetone and it is chloroform. It is acetone and chloroform. I am just showing you, just this will make a bond. This will make a bond. You see the trick how I write CH3 CH3, and if ONH makes bond, so it will be in this way, and whole part will be in other hand one hand, two hand, four hand, balance is 4. So in other hand, this is CCl3. This is the structure of the compound formed when acetone is made to react with chloroform, and its name is chloritone. So sometimes it is asked chloritone is prepared from, answer this and that. What is the use of chloritone? It is number one, stress releasing medicine. Number two, hypotonic, means sleep inducing medicine, sleep inducing medicine used as anesthetic purpose, or sometimes used against diarrhea in dog when there is excessive diarrhea in dog, that is given for gastritic purposes. So chloritone is very important. It is a type of medicine. Next one is, it is very important question, very fine question, I think, very fine, and you need to know its explanation. You are asked to arrange the order of nucleophilic substitution reaction, means you have to substitute chlorine by a nucleophile. Am I right? Nucleophilic substitution, it is not easy, it is tough, because aromatic compound not easily show nucleophilic substitution reaction. Electrophilic substitution reaction is shown by the aromatic compound, and under some drastic condition we can break this bond. So to substitute this chlorine, to release this chlorine, we need to break this bond, and it is very difficult to break this bond until unless it's drastic condition. So there is one condition here, nitrogen, it is an electron withdrawing group and it destabilizes the benzene ring. So due to the resonance with the outer electron involves with the electrons of carbon of benzene, and this becomes partially double bond, hence breaking of chlorine and Cl of benzene is very much tough. So when nitrogen group is there, so it facilitates the breaking of the partial double bond formation due to the resonance phenomenon. But here again, though there is no nitrogen group, but it is simple chlorobenzene, FML charge is there. Under drastic condition we make it for substitution reaction. Now here what's happened, Cl3 is plus I group, it pumps electron. So double bond character, the density again increases and double bond character will become more and more intense. So plus I groups will act against the substitution because this bond becomes stronger. And here again this is lone pair. That lone pair instantly goes double bond and the bond withdraws and makes bond in this way. Am I right? So there is hyperconjugation, so to show you the plus I capacity, but there is directly lone pair, so it is more easier. So it will strongly oppose the breaking of this bond due to the pumping of the electron. So it is highly viable, feasible through a substitution reaction. Here is this, because it's destabilized. This is high, this one is second, this one is third, and this one is fourth. This is asked in PMT mains. So last question is again very interesting one, and you see an alkyl halide C3H13 C3H13Br. This is alkyl halide you are given. It is in entrance exam, it is asked on dehydrohalogenation give X and Y. It gives X and Y, dehydrohalogenation. Dehydrohalogenation, it gives X and Y. X on ozonolysis and Y on ozonolysis gives a lots of things. CH3, CO, CH3, CH3, CHO, CH3, CH2, CHO. It is not told that X on ozonolysis gives this, Y on ozonolysis gives this. It is given in general, X and Y on ozonolysis gives this product. So these are the hints. I will just take this one. First of all, you see there is C6H12. There are 6 carbon. Whether these carbon are in the long chain or not. 1, 2, 3, 4, 5, 6. And there is bromine. I will show you where the bromine will be. Am I right? Because dehydrohalogenation means there will be loss of hydrogen and there will be loss of bromine. But the question is whether the chain is with 6 carbon in this way or chain is with in this way. 1, 2, 3, 4, 5 and here 1 carbon. This may be the another possibility, because from the answer we see CH3CO CH3. CH3CO CH3 ketone very often comes with a compound like this. A lots of compounds are there where CH3 CH3 are side by side, and that on ozonolysis that alkene gives you ozonide. If there is double bond, alkene gives ozonolysis. Am I right? So if the alkene is that on dehydrogenation will get alkene from there. It is alkyl halide, will get alkene. So we are concerned with the alkene after dehalogenation. Whether if this alkene is like CH3CH3 side by side, then we will get CH3CH3 C double bond O. So CH3CH3 C double bond O in one option is given, means your alkene on dehydrogenation of alkyl halide, where the main chain will be side by side. So I will prefer this structure, not this one. So let me write CH3, CH2, CH3, CH, so let me write this structure in this way. Let's see, because that when there will be dehydrohalogenation and we need to get alkene, and if this alkene, if CH3CH3, if I get want to get by side, then this CH3 group and CH3 group will be side by side, and bromine would be side by side of this one. Bromine will be the next carbon atom, because when hydrogen from any one of will go, one bromine will go here. There is 2 chances of dehydrohalogenation. Already I have shown you, because here there is bromine. From this bromine, this is beta 1, this is beta 2. So what you are getting 1, 2, 3, 4. What you are getting is that when beta 2, I told you a very simple rule, then with respect to this is beta 1, this is beta 2. The carbon, beta carbon which has less hydrogen, the hydrogen will be released from this one, will give you the major product. So less hydrogen is here. So I will release 1 hydrogen from here and 1 bromine here. So I will get CH3, C, CH3, double bond, C, H, CH2, CH3. So from less. And another, this is X. And another possibility is that from mode, this is major and Y will be minor. So if I release 1 hydrogen from here and 1 bromine here, so we will get here CH3, CH3, CH, CH3, C, bromine has been lost, and here hydrogen has been lost. So CH bond, CH, CH3. So this is Y, this is major and this is minor. So when will ozonize mean destructive reduction. So there in type of Y we will make this, we are simply getting CH3 CH3 or one CO group is there and another will be product. And on ozonolysis, this one we are getting CH3CHO in the option CH3CHO, and another one we are getting 4 1. So your structure will be alkyl halide of this alkyl halide will be 1 2 3 4, means 3 bromo 4 ethyl pentane. Answer is 3 bromo 4 ethyl methyl pentane. 1 2 3, 3 bromo 4 methyl pentane. Very interesting. So you managed to follow this one. Thanks a lot for watching the class. Don't forget to subscribe the class, because I am soon going to start the practice set in alcohol chapter, next chapter.